let's look at this example. We're going to take the area bounded by the curve y equals square root of x equals 1, and the x-axis. We're going to rotate that around the y-axis. So let's see, square root of x looks like this. X equals 1 is here. We're going to take this area inside of here and rotate it around the y-axis. So when we do that, we're going to get the other side over here, and a shell in here is going to look like this. All right. Let's look at this on the online calculator. If we look, our upper curve is square root of x. Our lower curve is just 0. And we're going from 0 to 1. So the shape that we're looking at is this. There. Helps if I actually put it on there where you can see it. All right, so this is the shape we're looking at. From the outside, it looks like a cylinder, but on the inside, it's sort of curving in. So one of the shells is going to look like this. And so that's what I've got drawn on the iPad. All right, so our thickness, the thickness is the first thing you want to come up with on these. The thickness is dx. And then we have to come up with the height and the radius. All right, the height in this case is square root of x, and the radius is just x. Now, how do I know that? Well, let's zoom in on this picture. On this one, it might be sort of easy to see, but let's label this stuff anyway, because on later examples it won't be quite as easy. I'm going to label this one down here in purple. All right, so this is the radius. And let's see, this point is the point x, and its y-coordinate is 0. And this, of course, is the point 0, 0. So the radius is the length of that line, so it's going to be the x-coordinate, the difference in the x-coordinates. And the height is going to be the difference in y-coordinates of this point. Now its x-coordinate is x, and its y-coordinate is square root of x. So the height is going to be the difference in their y's. So that's how we come up with this for the height and radius. So the volume of this solid object is going to be 2 pi radius, height, thickness, which is what we had up there. And our endpoints, we're going from one side of the shaded area to the other. And since we're doing this in terms of x, we're going to go from the x-coordinate over here to the x-coordinate over here. So let's see, what are those? Well, this is 0, and over here it's 1. So we've got to evaluate this integral. All right, so 2 pi integral, that becomes x to the 3 halves dx. When I integrate x to the 3 halves, I get x to the 5 halves with a 2/5 coefficient on the front from 0 to 1. So let's see, if we multiply it out, we get 4 pi over 5 times x to the 5 halves from 0 to 1. And of course, when we plug in the 1 and the 0, we just get 4/5 pi. That's our exact value. Now let's compare that to what the computer gives us. Let's see, right here, just with 10 shells, it's giving us a value of, it doesn't want to show up. It's giving us a value of 0.8 or 0.79. Not sure why. There we go. And if we put a bunch of these on there, it'll just get better. 1,000. Maybe that was too many. Yeah, there we go. Gives us, yeah, right at 0.8 pi. All right. Next one we'll do in the next video.